So what we're going to do, again, we've got, whoops, I need to open it. Sorry, give me a second to do that. So what we're going to do here is, this is focusing on parallel and perpendicular lines. So this resource originally was just created so that students had a few problems where they needed to compare the slopes to determine and justify if they were parallel, perpendicular, or neither. And in this case, they were given equations of lines in various forms. So some of them have been completely solved for y, some of them have not. Then they also needed to, given points that make a line, determine if they would be parallel or perpendicular. And then on this last page, they needed to, given a line and given a point not on the line, find and create a line that's either parallel or perpendicular. So what I want to do is take this and figure out ways that I can make it a little bit more interactive with students. And this is something to think about, whether the intention of the activity is for an instructional purpose or for like their independent practice purpose. So I'm going to focus this on a instructional purpose and find ways to make it interactive so that, again, the conversations in class can be guided by what they're doing on this Desmos activity. So let's say, so let me go back to my Desmos, and we're going to say this activity is slope of parallel and perpendicular lines. I'm going to call this an introduction, or if you wanted to call it notes or something. So just as a reminder, with how students go into student.desmos.com, I'm just going to show that real quick. So if I was to go to student.desmos.com and I go in here on the student side, because I'm not sure you guys have looked at the student side before, these are all of the activities that I've ever logged in and done. So like for your students, when they come in here, they can open previous activities they've done, or they can start something new. So titling your activity the way you want it to be is pretty crucial for students to be able to go back. So like, for example, if you're trying to go away from them doing any sort of like handwritten notes or anything they need to like, quote, keep for later, and you wanted to do it as a Desmos activity instead so that they're doing everything on screen, you can always go back and open it. So they can always refer back to this activity that they're doing. So let's say I wanted to do slope of parallel and perpendicular lines. And I know that the crucial thing here is students need to know that parallel lines have the same slope, perpendicular lines have a slope whose product is -1, or we usually talk about it as having opposite reciprocal slopes. So maybe first I want to do some sort of introduction to that. So let's say I'm going to go introduction to parallel lines. And I'm going to go ahead and put a note in here. Or maybe not even a note. I'm going to back up for a second. And what I'm going to do is I'm going to put in a graph. And I want them to see that parallel lines have the same slope so that they can then see that, and then we can go in and do a little bit of diving deeper into it. So what I'm going to do is I'm going to graph two lines. So I'm going to say y equals, I don't know, 1/2 x plus 2, and I'll do y equals 1/2 x. And I'm also going to put a couple of points on here because I know that sometimes students struggle figuring out how they're going to count the slope when they're not given points. And since this is an introduction, I want to give them everything they need right now so that I know that we can have a conversation about it later. So I'm going to plot the two intercepts. So I'm going to plot point -4, 0 and the point 0, 2. On this one, I'm going to plot the point -4, oops, that's 0, -4, then 8, 0. So now when students look at this, I know that they can see those 2 points so they can find the slope. So I'm going to put in a note, and I'm going to say these two lines are parallel. Or what do you think makes them and I'm going to give them a text input so that they can put their responses. I'm going to let them see each other's responses because this is simply me just seeing what they think. So when I preview this, instead of me coming right out and saying lines are parallel when their slopes are the same, I want them to see if they can figure it out. So this can kind of guide my conversation where while students are putting in their responses, I can go in and I can see who's saying what, and we can have a conversation about what people are saying. Let's say I want them to see the equation of this line, because right now I'm forcing them to have to find the slope, but maybe I want to give them multiple ways to do this. Maybe I want them to be able to either do rise over run, or maybe I want them to see what the equation of the line is. So what I'm going to do here is I'm going to go ahead and label. I'm trying to figure out how I'm going to do this. I'm going to put it right here. So I'm going to put a point at -2, 0. And these are just kind of like little things. No, that's not where I want it to go. -2, 1. That you can do where you might not think about it initially, but like trying to figure out how to make things look a certain way that you can hide stuff on a graph. So like I'm not actually making this point appear, but what I'm going to do is I'm going to just put a little label there. So I want them to see what the equation of this line is. So the label that I'm going to put is y equals 1/2 x minus 4. The key here though is if I just type in y equals 1/2 x minus 4, that doesn't look nice because it's not using math type. So a quick workaround for that is put these little backticks. And so this is the key that's above the tab button. So I'm putting a backtick around it, and that will turn it into math type. All right, now I did end up choosing something with a fraction, which actually does require one step farther. So you can do this two ways. I'm going to first show you how you can just copy and paste it before I do it from memory, because you might not be doing it from memory at this point. So 1/2, I want to get that in there to make it look right. So I'm just going to copy this. And then here where the slope was supposed to be 1/2, I'm going to paste it in. Because I don't expect you to memorize this, and you can do exactly what I just did. So like, again, I want the equation of this line to pop up for them. So I'm going to put it right here so it's easy for them to find. So I'm going to put it at the point 4, -2. And I do want it to appear the same color, so I'm going to change the color. And then again, I want this to be y equals 1/2 x minus 4. So actually what I'll do this time is I'm just going to copy that entire thing. I'm going to put a little backtick, and I'm going to paste it in there so that it pops up the way I want it to go. And I don't want these points to be visible for them, so I'm going to just click that to make the point go away. All right, now it also puts like the equation in a weird place, so you can change the location of it. So I'm going to put the equations, I'm going to put them to the left because it looks like that will be the easiest thing to see. And actually, I'm deciding that these might be hard to see, so I'm going to turn them black. And this is just the thought process that I go through a lot of the time when I'm making things. You just kind of want to work through it and see what it is that you like. All right, so now when students look at this, these two lines are parallel. What do you think makes them parallel? So now they have a couple things they can do. A kid might say that they found the rise over the run and each was 1/2. They could just look at the equation, but in the end, whatever students say, that conversation can be guided by the information that was here. So then I might do the exact same thing for perpendicular lines. So all I'm going to do is I'm going to take this, I'm going to duplicate it, and perpendicular lines. And so I'm going to change this to y equals -2 x plus 4. I'm going to move where this is also so that it's not right on top of where they intersect each other. So I'm going to move this to I'm going to put it at -6, -1, just to make it a little bit easier to see. Oops. Then I'm going to move this down here to the point -0, -4. And that was -2x -4. And then that point 80 needs to become the point -20. All right, so now maybe what I'll do is use pausing and pacing while students are doing this as an introduction, and maybe I'll let them do what's happening on this slide and what's happening on this slide, and then before doing anything from that resource that I showed you, conversation about parallel and perpendicular lines, use what they say to guide that conversation to see all the things that they're finding. And now let's get into the meat of taking this resource, which again is this, taking exactly what's here and doing more than just saying, is it parallel, is it perpendicular, what's so let's say I want them to work here. So I'm gonna not be looking at this screen anymore, so I might need you guys to remind me what's on there. So I'm going to put it as a table. And I'm going to call one of them line 1, and I'm going to call one of them line 2. Can you guys tell me what was one of the equations?
Y equals 3x plus 4.
And then the other one?
Y equals 3x plus 7.
All right, so now let's remember that all we've done so far is they've looked at parallel lines. We've had a conversation about what makes two lines parallel. They've looked at perpendicular lines. We talked about what makes lines perpendicular. So they're still going to need some leading in some way. I might not expect them to right away do this without any prompting. So I'm going to ask a few kind of guiding questions. So first I'm going to say, given the two lines in the table, determine if they are parallel, perpendicular, or neither. I'm going to bold it so that they see it. All right, so now there are some things that I want them to look for. I kind of want them to look for the slope. Maybe they know they're supposed to do that. Maybe they weren't paying attention before. I don't really know. But I'm going to give them a few guiding questions. So what I'm going to say first is, what is the slope of line 1, so that they have something to reference in the table. And I'm going to give them a place to enter that. And then I'm going to ask them, what's the slope of line 2? And then I'm going to give them a place to enter that. So right now, oops, this moved. But when they're looking at this screen, they've got this table. I've asked them what the slope is, and the reason I'm doing this is not only for them, but it's also for me as the teacher, because eventually I'm going to ask them, are the lines parallel, perpendicular, or neither? And I need to know what they're thinking to kind of help gauge that, because again, in this situation this year, I can't just look at my screen and see that kids don't. I need little cues for myself, because if they're getting something wrong, I need to know what the thinking was behind it, and they might not be willing to share it, you know, in front of their entire class. So then my final question is going to be, are lines 2 and 3 parallel? Oh, not lines 2 and 3. What am I doing? Lines 1 and 2. Parallel, perpendicular, or neither. And I'm going to give them some choices, because now this is where I'm going to be able to tell if they're right or not. And I can see that I need to go help a particular student. So perpendicular, neither. I know that the answer is parallel. And I'm going to bold my question And let's take a look at how this looks. All right, so now when students go in and do this, give them the 2 lines in the table, determine if they're parallel, perpendicular, or neither. I'm giving them some guiding questions to help kind of focus their thinking so that as we move forward, I'm helping them build that understanding. And then again, me as the teacher, I'm going to know what they're thinking. All right, so if a kid knows what they're doing, you know, they put in 3, they put in 3, they say they're parallel. And in this case, I have this dot up here. I'm not gonna go through right now how to make it come up as a check mark because that's a whole different session. And Javier has done one of these in the past, so I would say go check out that recording of his session on this if you want it to appear as a check. But in this case, as long as it's not an X, we're good. So the fact that they chose parallel, the dot came up means they're right. So I know this kid understands it. I don't need to go in and assist them anymore. All right, but you know, let's say a kid said that the slope was 4 and the slope was 7, and they said neither. Well, there's an X, and when I go here and I look at their screen, the fact that I gave this little bit of extra information, I now know that the kid doesn't know how to figure out what the slope is. So kind of using Desmos as a tool to figure out what kids are thinking to better assist what they're doing. And one thing that, you know, I've really come to think about using Desmos in the classroom, especially in this virtual setting, is it's almost easier, I think, to see what kids are thinking if you're asking the right questions, because, you know, in a classroom, you have to walk around and look at everyone's paper, and it takes time to walk around the class. Now, all you have to do is scroll through the dashboard to see what kids are doing, and you can also really easily share with the whole class. So let's say I had like the whole class, for whatever reason, came up with 4 and 7. I could stop everyone, I could share, we could take the responses that students were giving. I still, even though they say parallel, I still might want to go check out just to make sure that they knew the slopes were actually 3. Because again, I want to make sure that's information that they have. Okay, so for me, I would probably do the same thing with the rest of these, but I do want to show one aspect of something you can do with a table to show work. And Michelle, I know you said you do Algebra 1 and Algebra 2, and this could be something where there's steps to solving things, how you could use a table to make it more powerful for you so you can see their steps. So let me explain what I mean by that. What I'm actually going to do is I'm going to take this one, and I know right now I've got this one in slope-intercept form, and this one only requires 1 step. I'm going to change this up a little bit. So I'm going to do the same thing that I did before. So I'm just going to duplicate this, because pretty much everything I'm doing is exactly the same. The only thing that I'm changing is this information. So line 1. All right, can you tell me what those equations were?
Y equals negative 4x plus 1 is the first one, and the second one was 4y equals x plus 3.
All right. I'm gonna even adjust this a little bit more, and I'm gonna make this one be -3. No, wait, hold on, plus 3. I'm gonna put x on the other side. I'm gonna say -x plus 4y, and over here, I'm gonna put this on the other side. So I'm gonna say 4x. All right, so now this is gonna require a little bit extra of them. I'm gonna say int, be sure to solve for y. And what I'm gonna do here is I'm going to click these 3 dots, and I'm going to allow students to add rows. And I'm going to show you why in a second. Right now, if I go here, if they click there, so it's not kind of intuitive that it's there. So what I'm going to do is I'm just going to click here so that this line's going to appear first. So now they can come in here and they can do their steps to continue. So I want to give them that space to be able to work through and do all of the steps that are necessary. So they need to subtract 4x on each side. So they could go in and say, okay, the next step is to say negative 4x plus 1. So they can show you the process that they're doing. This one's going to require 2 steps. First, I need them to add x to both sides. So 4y equals x plus 3. And if I hit enter, I've allowed them to take more space. So now I'm going to divide by 4. So y equals 1/4 x plus 3/4. So now I've given them the space to do that work so they can better answer these questions. So now what's the slope of line 1? Negative 4. What's the slope of line 2? 1/4. Oh, let me key in the right answer this time because it was perpendicular. So if they choose parallel, they're not right, and I can go in and see what they did. If they chose perpendicular, I might want to go in and check that they solved this and put in the slopes of those lines. So I just did a whole bunch of talking through my ideas. What are some thoughts or questions that you guys have so far? If any.
Yeah, you're giving a super explanation, and this is really, really useful because we have lots of paper resources that just need to be what's the word?
Desmosified.
Desmosified.
Yeah.
You.
And at this point, I have not done any CL whatsoever.
Right.
So it's really about thinking through the types of questions that you would ask in class. And again, in a regular class setting, some kids are going to start responding, but the thing here that everyone is dealing with is, kids aren't talking about things. So how can we figure out what they're thinking? How can we figure out where their misconceptions might be? And it's about taking what we have and just asking a few more questions along the way so that we can figure out what they're thinking if they're not going to tell us. So just for the sake of time, I'm going to, on this resource that I have, I'm going to skip this middle part for now, and I'm going to go down to the graphing just so I can show you a few things about what we could do here. So, a big thing that we also have to do is, given a line and given a point not on the line, be able to graph a line that's parallel or a line that's perpendicular. So I'm going to come in here. I'm going to create a new slide. I'm going to create my graph. I'm going to edit my graph. Gosh, this is y equals 1/2 x minus 2. And then the point A is at 0, -2. And I want them to all be the same color. We're going to call this A. Where's point B? Can you just tell me that real quick?
Or 0, I think.
All right. 0 is going to be B. And then I have point P somewhere. Where's point P?
2, 2.
And I'm always going to preview this to see what the graph looks like. All right, so we're good. So this slide is going to be about graphing parallel lines. All right, so I did not know this until 40 minutes ago, but apparently you can make a line appear above AB to give proper notation. I don't know why this is how you have to do it, but this is how I have to do it. So given, and I want there to be a bar above AB, so I'm going to use a backslash, and I'm going to say overline, and then AB in these little brackets, and I'm going to highlight it, and I'm going to turn it into math type.
Oh,
For
wow.
some reason, that is the only way that this is possible. Javier showed me this morning. I don't know why there's no other way to do it, so I'm just working with that. This is recorded, so it will always be there for you to refer back to.
Ooh.
So I'm going to say given AB and point P. I'm going to say given AB. I'm going to ask you guys what you would like. Do you want this to be a sketch where they just plot a point, or do you want it to be a graph where they're going to drag points? Or do you want to see ways to do both?
Both, please.
Okay. All right. So given AB, what were you going to say, Michelle?
I agree. I want to see both.
Okay. All right. So given AB, I'm going to say, I'm going to first do this as a sketch. And so what's nice about this is if I change my mind to do a sketch, I can just go in and change it. So I can go back and forth without having to recreate everything. So I'm going to say given AB, plot, I'm going to say at least 2 points to create a line that is parallel to, and again, I can't just copy and paste it. We don't know why. And goes through point P. So now when a kid looks at this, you know, they have to go in here and they have to plot their points. All right, so now this is where you as the teacher have to figure out what's your intention with this. Do you want them to be able to visually see whether or not they're going to be correct, or is it something where you want to wait and see what students come up with and have a conversation about all of their results? Because, you know, again, what's nice is you can pull up a bunch of students' responses, you can share your screen, and you can talk about ones that might be right, some that might be wrong. It's really up to you. So I could stop here, or maybe you want them to work through some feedback so that they can adjust their answer if they're not quite sure. So let's say now CL is going to get involved a little bit here. So let's say I want them to see a line go through these points if they are correct, so that they can see what's going on. And this is where buttons are amazing. Buttons can control so many things. So what I'm going to do is I'm going to add a button, and I'm going to say C parallel line is how I'm going to label it. So this is going to make them see something. Obviously nothing's going to be shown yet because I haven't told Desmos what the parallel line is. And just real quick, I don't like how there's no space right here. So I'm just going to do a couple of things to make it look nicer for me, because I'm very picky about how things look. All right, so now I need this button to actually show a parallel line. There's a couple things involved with this, and I'm going to go through it and then I'll go back and explain what I did. So what I know the parallel line is it has to go, this y-intercept would be 1. So I know that y equals 1/2 x. Whoops. I know that this is a parallel line, and that's eventually what I need them to see. Right now, if I don't do anything, they're going to see it, and they haven't done any work at this point. So what I need to make happen is I need this line to appear once they press this button. All right, so I'm going to do a couple things, and I'm going to explain it as I go, and I'm going to go back and refer to what I did. So right now, this line is appearing all of the time because I have not set any conditions to ever make it not be visible. So I need to set a couple conditions so that it's not always going to show. So I'm going to use this squiggly bracket, and I'm going to say P equals 1. I do not want to add the slider. I just want to keep it like this because this is going to be a variable that I need. And this variable is going to go into my CL. This button also controls everything. So I'm going to call this a parallel button. So I'm going to go into the CL of my graph. And the variable was P, but as we know, variable represents a number. So number P. When they press the button, I want that line to appear. And that button, so when parallel button dot press count is greater than 0. So when the parallel button has been pressed, the condition is 1, otherwise 0. So what's going to happen now is they've got nothing. I'm going to plot some points. Let's say I do something crazy. See parallel line. Whoops, some of my points didn't land on there. So a kid could start thinking I've done something wrong. This line is now there forever. So there are other things that we can do, but let me go back and re-explain how I got that line to appear. Again, this line was the parallel line, but I didn't want it to show all of the time. I only wanted it to show under a single condition, and you'll notice this warning is there. In this case, that's okay. That warning really just means that this is only going to happen under a certain condition because of this variable. The variable was P. I said P equals 1. So when the condition 1 is met, this line is going to appear. So in the CL, I needed to say that number P, when the parallel button has been pressed, that condition of 1 is met, so my line will show up. Otherwise, 0, so nothing's going to happen when the button hasn't been pressed. Thoughts, questions on that?
Need to process that a little bit.
Okay.
I love the results, but I need to.
And I'm gonna just take it one step farther. So, you know, your kid plots their points. Maybe I don't want them to change what they've done because as the teacher, because right now, if I was wrong, I can just get rid of what I did and I can put it there and I can be right. And no one was ever going to know that I was wrong the first time. But maybe you as a teacher, you're going to have multiple ones where they're doing this and you want to see over time, are they getting better at this or are they continuing to do the wrong thing? So maybe I want them to not be able to sketch anymore. So once they see the line, I want to know what they did originally because I want to know if they're doing the next 5 slides wrong every single time, or are they getting a couple wrong and then starting to progress and do better. So I can make the sketch not happen once they have pressed that button. So I'm going to go back into the CL and I'm going to start saying disable sketch, and I don't have to type all of it. Desmos gives me the options of what it can do. So disable sketch. So I want the sketch to be disabled again when they've pressed that button. So now what's going to happen is they can plot their points, do whatever they're going to do, see the line. Now they can't change their answer. And me as the teacher, I know they've done this one wrong, but as they move forward, I can see if they're getting better. It is 8:30, so if you have to hop off, you can hop off, but I do want to show a way of doing this, maybe not with the sketch, but doing it as a graph where they're dragging points. So I'm going to keep this here just so later when this activity is done and you want to go back and refer to it, everything is still there in the coding, because again, after this, I'm going to send this activity to you guys. So I'm going to just duplicate the screen, and I don't want to do it as a sketch anymore. Now I want to do it as a graph, because what I want them to do is I want them to be able to drag some points around. And some of the things that I'm about to show you, I did not come up with this idea myself when I did this session yesterday. These were some questions that people asked. So I'm just kind of going along with what people wanted to see yesterday also. So let's say, so I don't want this anymore. I'm going to get rid of this because they're not sketching their own point anymore. But what I am doing is I'm going to give them the ability to take a point and drag it around. So I'm not going to give it a number. I'm going to give those points some sliders, and I'm going to add sliders. So the point AB, students will be able to take this and drag it around. And as you can see right now, I can go to like all of these in-between numbers. I only want them to do integers. So for A, I'm going to put a step of 1. And for B, I'm going to put a step of 1. That way they can only go to whole numbers and make it a little bit easier for them. All right, so now I'm going to start on top of P. So now they can drag this point. I took this away, and I took this away for a reason. If you want to do it the way it was done before, you can still do the same coding as last time. But yesterday I had someone ask me, okay, if I drag the point, instead of seeing the parallel line, can I make it be so that they see the line between their point and point P so they can visually check and see, do my lines even look parallel, or do I need to change something about it? So the answer to that is yes. what I'm about to do is not something a student will ever have to do. This is something I, as the teacher, I have to use with my knowledge of equations of lines. So basically what's going to happen is I want them to drag this point, and I want the line connecting these 2 points to appear. So I'm going to write the equation of this line. So I have point P, and then I have this AB. But remember that AB is changing wherever they put it. So my X value is A and my Y value is B. So I'm going to use point slope form. So I'm going to say Y minus B equals, and I'm going to need the slope of this line to come up. So this is the point 22. So the slope between these 2 points would be B minus 2 over A minus 2. And then continuing using point slope form, so X minus A. So now what happens is when they drag this point, they're seeing the line that connects their dragging point to point P. But I don't want this line to always be there. I want them to drag the point, and then I want them to see the line. So I'm going to change this to say see my line. And now this is what I want to come up when my condition P equals 1. So now they put the point wherever they want it to go. So let's say they think this made a parallel line. See my line. Okay, well, that's not going to work. So they might need to start moving it to make it work so they can play through their idea and visually see what's happening to help guide them to creating that parallel line. Thoughts, questions on that? I know I just did a lot.
That's cool. I like that, dragging the point and having it manipulate the line. That's cool.
I do too, because then they can see the results of their thinking.
Yeah.
Correct. Now, the next thing, I'm going to show one more thing that you can do. Because again, let's say when kids do this, when they see their line, maybe you don't want them to be able to change this anymore, because again, as they progress through this activity, you want to see, are they getting better, or are they continuing to do the wrong thing over and over and over again? I always could also, if I needed to give them some prompting, I could say, what is the slope of AB? Maybe I need to give this for some kids, and then give them a place to put in their input. So maybe now they're going to do something before they actually start moving something around. But what I can do also is I can make it so this point is no longer draggable under a certain condition. All right, so there has to be a time when you can drag this point, and then there has to be a time where you can't drag this point. So what I'm going to do is I'm going to go here, I'm going to hit enter, and I'm just going to put the point AB again. So now it's technically there twice. One time you can drag it, another time you cannot. When do I want them to be able to drag that point? So like thinking about the button, are they going to drag this point when the button has been pressed or when the button has not been pressed?
Has not been. That's been
So, right, and so I'm going to say when P equals 0, it's still going to allow them to drag it, but once the button has been pressed, it's not going to be a draggable point anymore. And you'll notice it went away here because again, it's only going to show up under a certain condition. So now they can drag it, boom, boom, boom. They put it where they think it goes. See my line. They connected the line. Now they can't move it. So they can see that they did not create parallel lines, and you can go in and try to figure out what happened.
Wow.
So again, endless possibilities. It just depends on what it is that your intention is with it. I mean, and remember when I first started this particular slide with sketching points, there was still no CL involved because you always have the power of using the pause and pacing feature to share student responses with each other. Or again, if it's something where they're going to do multiple slides of a similar thing and you want to see their progression as they go on to see if they're getting better, you can use CL to stop them from doing more responses once they see the answer. So again, you can see they did 5 slides, they did every single one wrong. They did 5 slides, they did the first 2 wrong, but they figured out what happened and they did the rest correctly. And it's powerful for them and it's powerful for you.